Hello guys, welcome to the channel, and today we are going to look at the loan eligibility prediction system using support vector machine model. So first of all, let's import our data set here. This is our data set. Let's import it. It's called train data set. Let's import it. It's here. It has been imported. So guys, first of all, we must import the dependencies. That's the libraries we are going to use, Python libraries. Import the first library is the NumPy. We import it as np. Import the pandas used for reading the data set files. That's the CSV files. Import the pandas as pd. Let's import the cbon as SNS. Import warnings. Then we say that the warnings dot filter warnings ignore. From the skline dot model selection, import the train test split. This one is used for splitting our dataset into two. Then from skline import the svm. Svm is our model that we are going to use it to train our model. So from skline.metrics import accuracy score. This accuracy score is used for getting the accuracy of the model. Then import matplotlib.pyplot as plt. This one is a library, Python library that is used for plotting graphs and charts. So let's run the code. So after that, we go to data collection and processing. Here we load our data set. So loading our data set, say data test, that's our variable, equals to pd.read underscore csv. So let's import our data set. So we go there. Here's our data set. So we copy the path, then we come and copy paste it here. That's our, then we run the code. So train dataset.head, we are reading the first 10 rows of the data test. So here we are going to look up the number of rows and columns. So we use the dot shape method to get the number of rows and columns. So here we have 614 rows and 13 columns. So that's statistical measures. We say that this is our data test dot describe. It shows us the statistical measures of our data set. So it has shown us the count, mean, standard deviation, mean up to maximum. So after that, we expand the number of missing values in each column. So data test dot is null dot sum, you get there. So here the number of missing values in gender column, you have 13, married column you have 3, dependents column you have 15. So to make our model work better, we must fill these values, the gender value, the married value, dependence values with mean or mode, so that to improve the accuracy of our model. So this is the method we are going to use, filling the missing values. So the data test gender, we are going to fill in with the mode method, the mode. The married, you're going to use them with the mode. The dependence mode, so here the loan amount, we are going to use the mean to fill the values. After filling the values, we need this, the dependent variables. We have the positive sign in our data, so we must restrip it. We must remove this, the positive value, because it is not needed. It cannot be used in training our model. So after that, we must change the categorical values into numerical. So the married, we are going to encode it. Where there's no, we put 0. Where there's yes, we put 1. Education, we are going to put not graduate 0, graduate 1. The self-employed, where there is 0, we put, where there is no, we put 0. Where there is yes, we put 1. So we must encode it so that it can fit into our model. So after that, let's check the values if they have been filled. We use the data test.is null to see if the values have been filled. So if you run the code, you can see that it has been filled. Every column is 0, 0, 0. So let's run the code to see if it has been encoded. So you can see the gender values 1, 1, 1, the married 0, 1, 1. So that's what we want. So after that, let's encode. We've forgotten to encode our property area. So the property area, we are encoding it. Where this rural, we put 0, semi-urban 1, urban 2. Then we put in place true. So when you say data test.head, we get that our property area has been replaced with zeros and ones. You can see it. Property area is 2, 0, 2, 2, 2. After that, we see if our dependent variable, the dependent column, it has been replaced. So you can see here there's no plus positive sign. So number of 0 dependents 360, number of 1, they are 102, number of 2 dependents, they are 101, the number of 3 dependents, they are 51. So let's go to data visualization, check the education status to see if one is eligible for a loan. So this data visualization, we have two types. We have the bivariate analysis and univariate analysis. In bivariate, you see this graph, we have used the sns.count blocks. In the X, we have put education, HUE, loan status, data. This is our data test. So this is the bivariate analysis. So the education, the not graduate, the number of those who are not eligible for loan, there are few, but those who are eligible for loan, they are at least they are larger than those who are not graduated. So let's analyze the graduate part. So those who have graduated, they can get, they're not so eligible for the loan, but those who are graduated, they are eligible for the loan. So after that, we get the marital status, where we see the married and not married. Here I put sns.count plot, x is equals to married, HUE loan status, data is our data test. So you can see the not married and the married using our bivariate analysis. So after that, let's move to histogram. We visualize using the histogram a normal probability plot. Say that from scipy import stats, from scipy.stats import norm, sns.displot to bucket data test. We are using our application income, then fit norm, fig. Then after that, you can see our histogram. Here is it. It should be like this. After that, let's plot our histogram. So here we are plotting the application income, application income, and the loan amount. So the graphs are drawn here. Let's see them. This one, let's see them. The graphs are drawn there. After that, let's look at the gender and the application income. The gender, so we are plotting the gender. Look how the gender and how they get the application income. So if you run the code, you can see that the male they get low amount the application income, but ladies they get higher, they get paid higher. So get the married and the application income. Let's plot the married and the application income. So you can see that those who are married they get the low amount, and those who are not married they earn a lot. So after that, let's draw our correlation matrix. We see which variables are correlated. So say that comat is equals to data test dot correlation, the core method. F is equals to plt dot subload 12.9. So when we run our code, is our correlated matrix. So you can see here that let's analyze this correlated matrix. You can see that the credit history is correlated the loan term. Then you can see here that the loan amount, let's see there, the application income is correlated with the employment. So even here you can see that the property area is correlated with the loan status. So after analyzing that, let's do what we call the univariate analysis. Univariate analysis is the single. We are looking, when we run the code, see the gender, we are plotting the gender, married and dependents. So if you plot a graph, you see that the gender, those who are male, they are more eligible than those who are female. Married, those who are married, they are more eligible than those who are not married. Dependents, those who have 0 dependents, they are more eligible than those who have 1, 2, 3 dependents. So after that, let's look at another univariate analysis where we compare the education, self-employed, and the property area. If you run the code, run the code, you can see that those who are graduated, they are more eligible than those who are not graduated. Self-employed, those who are not self-employed, they are not eligible, but those who are employed, they are eligible. Those living in, you can see that those living in urban, this is the semi-urban, urban, the rural. So let's the box plot. Let's plot the box plot to understand the distribution and observe the outliers. So say data test dot box plot column application income. So this is our box plot for application income. This is it. Then plot for the box plot for loan amount. This one is that running. So in SVM we need to split our data set into two. So we have the X variable and the Y variable. So X variable, we are in the X variable, we are dropping the loan ID and the loan status because they are not used in training a model. So the X will is a variable that will hold the loan ID and the loan status. So Y is the data test that will hold the loan status. So after separating the data, so we print the X and Y. This how should be printed. So after that dividing the given trained dataset in form of features and target variables, and further making use of get dummies. So we are using this .ilog to get the dummies. If you run the code, yeah, then train test split. We are dividing our data test into X train, X test, Y train, Y test. So X train, X test, Y train, Y test equals to the train test split, which is X and Y. The test size we are testing is the 20%. Specify Y. Random tests, you can put any value, 0, 1, 2, any value you want. So we print X shape, X train dot shape, X test dot shape. So we want to see how many values they are trained, how many values are tested. So we can see here that there are 614 rows, 11 of them. Thus we have eliminated the loan ID and the loan status. So the X shape is 491, X test is 123. So we say that in this project we are going to use the support vector machine model. So classifier equals to svm.svc into bracket the kernel. We are using the SVC model to train our support vector machine. Then classifier.fit, we are fitting our model into X train and Y train. So after you run the code will take some minutes. Oh, sorry. Let's run it from the app. Let's run it from here. Supporting the code. Let's run it. let's run it. Yeah. Let's print it. The model will take some minutes while it's training, so you should understand that this support vector machine is type of the supervised learning algorithm. So we are fitting the model into the X train and Y train. We want to check the accuracy of our model. So let's wait it for it to run. It's now training the model. It's now training model. Let's wait it for training. So as it is training the model, let's continue. We say that ypred equals to classifier dot predict x test. We are predicting the x test. So from sklearn import matrix. This matrix is going to help us to get the accuracy of our model. So the model accuracy, how often the classifier is correct. So this one is used to print the accuracy score. So let's wait for our model to finish training so that we can see the so it has finished. So let's run this code for the accuracy score. So our accuracy for this model is 80%. So after that we plot our confusion matrix. So we get the confusion matrix. So from sklearn.matrix import the accuracy score, confusion matrix, classification report, plot confusion matrix. So we are using this our ypredict to plot our confusion matrix. So our confusion matrix, this is the array. Let's plot it for further understanding. So this is our confusion matrix for support vector machine. So for you to understand this confusion matrix, we have the true labels and the predicted labels. So so in this column, oh sorry. So we have the true labels and the predicted labels. So 1 1 this 85, these are our true positive values. Then we have 0 1 these are false positive values. Then we have 0 0, these are our true negative values. And then we have 1 0 these are false negative values. So let's get the F1 score, the precision score, and the recall. So these are formula for getting the precision score, recall, and F1 score. Thank you guys. Continue subscribing to the channel for you to get more content on the machine learning algorithm.